So I want to take another quick look at hydrates, just in case you might have missed something in class or were absent or something like that. I'd like to have a sample problem online for you to use for review. So sodium sulfate decahydrate. If we were going to address this hydrate, first of all, we need to write the formula for it. So it's sodium sulfate. So that we just write just like we would normally do. We know Na is +1 and SO4 is -2. So I end up with Na2SO4. And then it's decahydrate, which we know means 10. And so we put this little dot that's like a multiplication sign. But in chemistry, it really sort of means addition. It means those 10 waters are loosely attached to every sodium sulfate. So we call it sodium sulfate decahydrate, and although I know math is a multiplication sign, it is addition in here. So what we typically need to do for hydrates is we need to find the mass percent of water in the hydrate. And so we're going to do the gram formula weight for sodium sulfite just like we have been doing. Nothing's changed there. So I have 2 sodiums, I have 1 sulfur, and I have 4 oxygens. And I'm going to go ahead and multiply them by their weights on the periodic table. So I have 23.00 grams, I have 32.06 grams, and I have 16.00 grams. And I multiply them through, and I get 46.00 grams. I get 32.06 grams, and 16 times 4 is 64 grams. And then I go ahead and I total that. So 142.06 grams. That's the weight of my sodium sulfate. But I still need to do the weight of the decahydrate because that's part of the compound. And yes, I could list all of them together and get one total, but because I'm going to need the weight of the water individually, it makes sense to do them separately because ultimately it will be less work later on. So I have my water, and so it's H and it's O. And I have 10 times 2, or I have 20 hydrogens, and I have 10 times 1, or I have 10 oxygens. I'm going to multiply them by what they weigh, so 1.01 grams, and multiply it by 16.00 grams, and it's 20.20 grams, and 160.00 grams, and 180.20 grams. Now, to find the total weight of this compound, to find the total weight of this, I need to add these two numbers together. So I'm going to take my total is 142.06 grams plus 180.20 grams, and I get 322.26 grams. Now, I've never seen a problem where you have to find anything other than the percentage of water when it's a hydrate. Although you could do the amount of sodium in that, the amount of sulfur in that, the amount of this oxygen in that. Typically, the only thing that's ever asked is what percentage is water. So in this case, let me switch colors here. I need to take my total mass of water. So mass percent of water is going to be 180.20 grams, because that's my grams of water, over my total mass, 322.26 grams, times 100, which is equal to 55.92%. So there you have in hydrates. The biggest mistakes that I see people make in hydrates is that they treat this as a multiplication sign instead of adding them together, like we did here. You could also find the mass of one H2O and then multiply that by 10. It's going to give you the same number here, and I don't mind which way you do it. I tend to always set it up this way, but know that either way is exactly the same thing. And that's the whole thing for hydrates.